So last time we set up some layout transitions for the swap chain images that we render onto using these pipeline barriers. And I completely forgot to mention one more interesting thing about the barriers, and that's this dependency flags. So let's take a quick look at its type. And we can see that there are three basic non-provided by extension flags: by region, device group, and view local. And honestly, I don't have a full understanding of this myself, but from what I could collect in the spec, these device group and view local are pretty much irrelevant for us here, since the device group is about doing work on multiple GPUs in parallel, I think, and the view local is about multi-view render passes, like rendering both eyes for VR at the same time and stuff like that. Now, this by region is more interesting. From my understanding, it will scope the dependency even tighter, in a sense that if the commands around barrier operate on non-overlapping regions of the image, or rather a frame buffer, so basically our render attachments, they don't have to be ordered and can run in parallel. Now, what exactly a region is depends on the GPU architecture and the driver. And as far as I understand, it could be a single pixel, but also a tile of pixels on some GPU architectures like modern mobile ones, also known as tiled GPUs. So sounds like this can improve performance, at least on these tiled architectures. But do we actually need this for the swap chain layout transitions? Well, honestly, I don't know, sorry, but I think we don't. With all these weird interactions with the presentation engine, I don't think we can get any benefit from that. And I wouldn't recommend going with a very narrow dependencies if you don't completely understand the implications, since that can lead to bugs that are pure hell to figure out. So I'd say let's not add dependency flags here. Maybe I'm wrong and we'll revisit this later, but it's better be safe for now. Anyway, originally I planned to proceed with some actual drawing, with shader and everything, but then I figured, since we were doing so much synchronization in the last chapters, maybe we should resolve another very much related issue while our memory is fresh, and that is multiple frames in flight. You might have heard this term, but what exactly do we mean by that? Well, it's really just about not making the CPU wait while GPU is working. Because obviously all the draw commands and other work that we submitted for the frame will take some time on the GPU to process. And while that is happening, it will be great not to wait on the CPU side and start building commands for the next frame already. So we can submit the next frame's batch of GPU work as soon as possible and don't waste any time. So this frame in flight is generally a term for the frame that can be prepared without waiting. So let's see. Currently, we just have a single frame in flight, because in our main loop we wait for the frame fence before doing anything, and once it opens, so signaled, we close it again with reset fence and start recording commands. Then we submit them to the GPU, passing the same fence for signaling once the work is done. So the next iteration of our main loop will always stop and wait for the previous frame's work to be complete. So this is not ideal, because even if we put some CPU work before waiting for the fence, like updating our game state and whatnot, the GPU command recording will still have to wait, because we have a single command buffer, a single acquire semaphore to wait as swap chain images, and so on. So how do we deal with that? Well, turns out we can just duplicate all the resources that are specific to a single frame submission, put them into an array, and just cycle between them every iteration of our render loop. So let's see, what do we need per each frame? The frame fence tells us when it's safe to reuse the resources for the new frame, more or less. So that's definitely needed for each frame in flight. Then this acquire semaphore for the acquire next image is also pretty frame specific, right? Because we acquire an image every time we render a specific frame, and we don't want to wait or signal other frames. Then the release semaphore is per swap chain image, right? So if we acquire an image for the frame, we can safely use its release semaphore. So we don't need a copy per frame, because no other frame will be able to acquire the same image before we're done with it. And thinking about this, after all the changes, this release and also image ready naming is pretty confusing. Maybe we should rename it to something simple like present semaphore, because this is what it is essentially, right? A semaphore that unblocks presenting. So let's quickly do that. Just rename it here, rename the field in the swap chain structure, and rename the references. Also, of course, fix the reference in the initialization. Would be nice to have a rename functionality for Odin, but oh well. Now back to our per frame resources. We need to record commands also per frame, and we clear the command buffer every frame with this reset call, right? Makes sense. In a game you can render its world in one frame, but then player presses a button and the state changes, and it might happen that we need to render a completely different world for the next frame. Or at least something in the world can change, appear, disappear, and stuff like that, right? This means that we also want separate command buffers per frame, because we cannot reuse the command buffers while they are in use by the GPU, right? And since we are resetting the whole command pool rather than individual buffers, as it's recommended for performance, we also need separate command pools per frame. And that seems to be everything that we need for now. We don't have anything more going on in our frames so far, so let's introduce a structure with a per frame data. I guess we can call it like that directly, per frame data. And as discussed, let's add a fence, the acquire semaphore, the command pool, and the command buffer, right? Now we want to add an array of those to our globals, but how many frames in flight do we need? Well, as usual, it always depends. You balance this depending on what you are trying to build, but I'd say 2 is a great starting point. With that number we can make it so that the CPU is able to record commands while the GPU is busy doing the previous frame's work. That said, let's actually introduce a handy constant for this, something like this, num frames in flight 2. And while we are at it, let's also move the desired number of swap chain images into a constant. So let's replace this 3 in create swap chain with something like num swap chain images, and define it next to our num frames in flight. Feels kinda satisfying how the name widths align here, right? Now, if we think about this, the number of swap chain images should be at least the same as the number of frames in flight. Because, well, we need an image to draw a frame onto, right? But it's even better if the swap chain have at least one more image. So one image can be presented and 2 more are available for the frame rendering work. So yeah, let's use this constant to define our array of per frame data, something like this, a field which is a fixed array. Now on every render loop iteration we want to cycle between the frames in flight, right? So at the first iteration we work with the frame 0, submit it, and without waiting, in the next iteration we start preparing the frame 1. Then after that, on the third iteration we cycle back to the frame 0 and use its resources. And if for some reason frame 0 has not been completed by the GPU yet, its fence will be still blocked, we're gonna stall the CPU and not try to reuse the resources that are currently in use by the GPU. So to track that, we also need some kind of frame index field here. And it's such a small number, we can maybe use a U8, even though that doesn't really matter. So now let's go to the place where we create all the per frame resources, like this command pool and command buffer, and basically move them into some create frames function, like this, right? Let's also add a cleanup with the deferred destroy frames call. Let's create those functions. So here we just simply create all the Vulkan resources that we need for each frame, right? So let's start moving our per frame resource creation here. So basically we can take all this stuff, right? The command pool, the command buffer, the semaphore, and the fence. Paste the code here. Remove the command pool local variable because we're gonna store it in the frame field, like this. Let's comment out the deferred destruction because this is something that we are gonna move into the destroy frames, of course. Fix the reference here. Let's remove the command buffer local variable because again we're gonna store it in the frame. Actually store it in the frame. Do the same for the acquire semaphore. Remove the variable, store the value in the frame instead, and do exactly the same for the fence. Something like this, right? Pretty straightforward. Let's just move all the destruction into the destroy frames procedure. So we add a loop. Again, per each frame we simply destroy the command pool, which will free the allocated command buffer as well. Destroy the semaphore and the fence. Now we can go back to our render loop and just fix all these references. So first we need to get a frame, right, from our array. Maybe we should rename the field to just frames to make it look a little bit less awkward. Fix the reference to the frame fence, to the acquire semaphore, to the command pool. Maybe introduce a short local variable for the command buffer because we will need to reference it in all the command recording functions. Fix the acquire semaphore reference here, right? Fix the frame reference here. And now, basically, after we queue the presentation, we simply increment the frame index and wrap it around according to our desired number of frames per flight, right? Something like this, right? We use the modular operator, just basic programming. So let's see if that works. And yes, it does. That's pretty simple. Now, it's totally possible that I messed something up, and it's kind of hard to tell because we don't even have anything being rendered really apart from our basic screen clearing. So I might have to fix it later, but the basic idea is exactly this. So next time let's actually draw at least a single triangle and see if it all really works. So stay tuned.